Hello, today we're going to continue chapter 9 and we're going to finish up section 9.1 today talking about the ellipse. So, today we're going to look at a new way to write an equation for an ellipse in what's called general form, just like we had for circles. So for the general form, we've got these values a, c, d, e, and f. You'll notice we are going to miss the letter b. And that's because if there is like a term that could be here that would be like a bxy, which we're not going to deal with because that would actually take an ellipse and turn it sideways or like rotate an ellipse, which we won't be doing. But that's why we're skipping the letter b. So the general form for ellipse is ax squared plus cy squared plus dx plus ey plus f equals 0. These are all constants. These are all just numbers. But for it to be an ellipse, there are a few rules. First of all, a and c, neither of these can be 0, so we actually have to have an x squared and a y squared term. We can't have 0 of them. And then also, a and c must have the same sign, so they must either both be positive or both be negative. If one were positive and one were negative, then we would have a different type of graph that is not an ellipse. So what we're going to look at is we're going to look at how to take an equation that's in general form and write it in standard form, and then find all the parts and graph it. So here's an ellipse in general form. You can see that this is the value of a and this is the value of c, and you can see that they are not 0 and they are both positive, and that's how I know it's going to be an ellipse. Now, if you remember back to how we did this for circles, we're going to use a similar method, and that is we're going to complete the square twice, once for x and once for y. So what I'm going to do here is I'm going to group my x terms together. So I'll write 4x squared next to minus 8x, and then I'll group my y terms together, and then I'll move that 49 to the other side by subtracting 49. And now this is the part that is now not like a circle. When we had a circle before, we were just able to divide by whatever number was here because that number was the same. But you'll notice if I try to make this one by dividing everything by 4, all of a sudden this number becomes 9/4 and that number is not 1. But if I try to divide everything by 9, then this would be a 1 and that's not a 1. So the problem is I'm trying to make both of these numbers 1 at the same time. And I can't do that by dividing. So here's what I need to do. I'm going to factor out a GCF. I'm going to basically use, it looks kind of like grouping. I'm going to put these two terms together, the x terms together, and I'm going to factor out a 4 from just these two x terms to get this. So I factor out a 4, and now that's x squared. Factor out a 4, and that's now minus 2x. And then I'll leave myself a blank here. That's the number I'm going to fill in here in a minute. And then here, from the y terms, I factor out a 9. So I factor out a 9 from these two terms, and that becomes y squared. 54 divided by 9 is 6, so I get a minus 6y there, and again, I'll have a blank here. And now you can see inside these parentheses here, I have made a 1 for both of these sets. So now what I'm going to do is I'm going to add half of b squared right here. So half of negative 2 is negative 1. I squared, I get 1. And now on this side, I have to keep it balanced, so I have to add the same thing. However, I am not going to add a 1 here because that's actually not the same thing as this. Even though this looks like a 1, it is the number 1. However, if you look way out here, that number 1 is actually being multiplied by 4. So on the left side of this equation, this 1 is actually a 4 times 1. So I actually have to add a 4 times 1 over here to keep it balanced. So 4 times 1 is just 4. So to keep it balanced, I have to actually add a 4 to the right side of the equation. And then here, half of negative 6 is negative 3. I square that, I get 9. But this is actually not a 9 on this side because it is being multiplied by 9. So on this side, it is actually a 9 times 9. So if I'm going to put a plus 9 right here to keep it balanced, I have to put a plus 81 here, because that's 9 times 9. And that's the part of this process that's different than circles, and that gets a little tricky. From here, though, I can just simplify this side by adding those numbers together to get 36. and then I factor these. That's the whole reason that I completed the square, is because now this is factorable into x minus 1 squared. I still have that 4 out in front. And then here, this is going to be y minus 3 squared. I still have that 9 out in front. And now, to get into standard form for an ellipse, I want a 1 here. And the way I'm going to get that is I'm just going to divide everything by 36. So when I divide everything by 36, I simplify this fraction. 4/36 becomes 1/9, and 9/36 becomes 1/4. And now my equation here for the ellipse is in standard form. Then I'm going to identify the center and the vertices and graph it. So the center, you can see, is at 1, 3. So I put the center at 1, 3. In the x direction, the square root of 9 is 3, so I move 1, 2, 3 units to the left and 3 units to the right. In the y direction, the square root of 4 is 2, so I move 2 units above and 2 units below. Then I draw an ellipse through those 4 points. And then I also need to identify where the foci are. The foci are going to be on this major axis here, since this way is longer. This is the major axis. But I need to find out how far away the foci are from the center by finding the value of c. So I use this formula, b squared plus c squared equals a squared, and I plug in my values for b and a. b is 2, a is 3, and then, I'll get 9 minus 4 is 5, so c squared is 5, so c is the square root of 5, which would be a little more than 2. So that's how far away from the center I move to the left and right to get to the foci. So the coordinates of the foci are going to be, the coordinate of the x coordinate of the center plus or minus the square root of 5, comma, and then it will have the same y coordinate. As you can see here, both of those values have a y coordinate of 3. All right, let's take a look at another one. And actually, how about you try this one and then press play when you're ready to check. All right, let's see what you did. Group x's together, group the y's together. Here, a is already 1, so I don't need to factor anything. Here I need to factor out a 4. Then we add half of 6 is 3, that's 9. This is really a 9 times 1, so that is just a 9, so I add 9 to keep it balanced. Here, half of negative 2 is negative 1, squared is 1, but this is really a 4 times 1, which is 4. Next, I add those up, I get 4. I rewrite these in factored form. I want that to be a 1 next, so I divide everything by 4. Then I simplify. There's nothing to simplify here, and then 4 divided by 4 is just a 1. And now there's the equation for my ellipse in standard form. So my center is at negative 3, 1. In the x direction, the square root of 4 is 2, so 1, 2, and 1, 2 gives me the vertices. And then the square root of 1 is 1, so it's just 1 above and 1 below. So there's the graph of my ellipse. To find the foci, I use that same formula, b squared plus c squared equals a squared. b is 1, a is 2. I plug that in and I get that c is 3. So the square root of 3 is how far I have to move to the left and right of the center. So the coordinates of my center are negative 3 plus or minus the square root of 3, comma 1. So that's how to go from general form to standard form and graph an ellipse. All right, last thing we're going to look here at 9.1 is to solve some real-world problems using ellipse. So a semi-elliptical, that means a half of an ellipse, a semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Your truck has a width of 10 feet and a height of 9 feet. Will your truck clear the opening of this archway? So here's what we're talking about. I'm going to draw this picture here from, a view behind the truck. It's about to go through the archway. There's my archway. You can see the height of the archway at the very top is 10 feet. You can see the height of the truck is 9 feet. So clearly we're going to have a foot of clearance right here in the middle. But that's not actually the part that I'm worried about. If the truck's width is 10 feet, that means from the middle to the edge of the truck is 5 feet. And this part of the arch is actually lower than 10 feet. But this part of the truck is still 9 feet. So the question is this, if I move this far away from the center, is it still tall enough for the truck to clear? This is the point that I'm worried about right here. So to use what we know about ellipses to answer this, what I'm going to do is I'm going to pretend that I'm going to basically put this ellipse on a graph. So I'm going to call the road here is going to be the x-axis. And then this line right here, the center of this ellipse, is going to be on the y-axis, like so. And now basically, I know that this point right here would have coordinates of 5, 9. Okay? And what I'm really trying to figure out is what would be the coordinates of this point. Is this point going to be lower than this point? And you can see that this point is right above the edge of the truck, so this point is going to have an x coordinate of 5, but basically, what's the y coordinate of this going to be? Is it going to be at least 9 feet? That's what I need to know. So to answer this question, I'm going to write an equation for this ellipse. So it's centered at 0, 0. So I start with an x squared, or x minus 0, which is just x squared, and y minus 0 is just y squared. And then in the x direction, the width of the entire ellipse is 40, which means half of the ellipse, the semi-major axis, is going to be 20. So beneath x squared goes 20 squared, and beneath y squared, the semi-minor axis, is 10 squared, because the height of the ellipse is 10 from the center to the top. So here's the equation of this ellipse. And now what I want to do is I want to figure out what the y value is for this point. So I'm going to plug in the number 5 in place of x. So I plug a 5 in right here, and 5 squared is 25. And now I have an equation, and I want to solve this equation for y. So first thing you can see that I've done here to solve this equation, I'm going to get rid of the fractions by multiplying everything by the common denominator. 400 and 100 both go into 400, so I multiply everything on both sides by 400. When I multiply this by 400, it cancels with the bottom. When I multiply this by 400, 400 divided by 100 is 4. And then 1 times 400. And now I'm going to keep solving this for y. Subtract 25 from each side. I get 4y squared is 375. Divide by 4, I get y squared is 93.75. And I take the square root, and I get plus or minus 9.68. So it's finding another point on the bottom half of this ellipse that I don't care about because that doesn't exist in my real world setting. So really, the truck has a clearance of 9 feet. I subtract that from 9.68, and you can see I've got an extra 0.68 feet of clearance. So my truck will safely pass underneath this archway. So, like I always say for word problems, I find it very helpful to draw a picture, label what you know as the first step. And then from there, we can write an equation for an ellipse and answer our question. So that's it for 9.1. As always, let me know if you have any questions.